ratchet. Too late.
Hey, it's on. Oh, welcome everybody. It's Monday. Welcome back. I know it's an hour earlier. So I know you're here, and that's good, man. And everybody's done a good job of coming here, pretty much. Unless you're sick or whatever. So, well, we got it's been a whole spring break, so I hope you guys remember about magnets. Magnets are these little things. They stick together. They have a field force in between them. You remember magnets? Y'all look. Hey, wake up. Look. Magnets, if the road has a south magnetic pole, hopefully you remember that north and south are attracted to each other with magnets. That's opposites attract with magnets. So if you want that car to get better traction, and the car has a south magnetic pole, the road has a south magnetic pole on it, and you want a car to get better traction, then you want if the road's south, the cars have a north magnetic pole, and then it'll be stuck to the road better traction. That'd kind of be cool if they did that, but it'd be very expensive, and then we'd all have to pay taxes. Today's assignment is called what is it called? I don't know.
Magnetism comprehensive practice.
That is correct. Magnetism comprehensive practice. So I put this left-hand rule thing up there. That's one of the things we got to remember for this. You guys remember how electric motor works? Maybe a little bit? Hey, some people do. That's good. So we've got, first there's the right-hand rule, and then there's the left-hand rule, and those both help us with the electric motors. So y'all know how magnets work in the first place? You remember? Y'all look, please. I'm doing a thing with my hand. I'm going to feel silly if you're not looking. Like this. This is what electrons do. They're always paired in oppositely spinning pairs. And most materials, when they spin, they make magnetic fields. Most materials, magnetic fields cancel out because they're oppositely spinning. I don't know. But not in iron, nickel, and cobalt. So that's why we got some things that can be made magnetic. Those metal things, only iron, nickel, and cobalt alloys, whatever. So anything that's moving has any moving charge, like electrons for those, make a magnetic field. So like your laptop plugged in over there, it's plugged into the wall. The charge is going from the wall to your laptop. So that's a moving charge. There's a little magnetic field around your wire out there. If you put a magnet next to it, that magnetic field made with your wire and the magnetic field from a magnet might interact, and then it would move. That's how electric motors work. But let's do left-hand rule, right-hand rule, so that we can get there. So with your thing plugged into the wall, it's coming out of the wall. My thumb's pointing in the direction of the current from the wall to your laptop. My fingers show the direction of the magnetic field. So if we're looking at it from this side, magnetic field goes around, which way is that? Counterclockwise. Lights on the shirt. If we use the left-hand rule, let's say that I take that same wire with the current going that way. So middle fingers for current, as we see right here. Middle fingers for current. So I'm pointing my middle finger away from the wall. If I point a magnet that way, point a magnetic field that way, remember it goes from north to south, so north pole here, south pole here, then the deflecting force of the magnetic field from that current going through there and the magnetic field that I put there will interact in a way that deflects that thing into the table over there. Y'all need to remember those for the practice today. One more thing about the Earth's magnetic field. Are y'all looking? Making sure you're awake. I know it's early. Earth's magnetic field, right? Remember the Earth's poles are named backwards. So there are names for the places, the North Geographic Pole and the South Geographic Pole. Those are backwards from the Earth's magnetic poles. Magnetic field goes from north to south, and that's why compasses point toward the south magnetic pole, which is located at the North Geographic Pole. It's weird, but that's why I'm reminding you of it, because that's weird to remember. Anyway, please try out this Magnetism Comprehensive Practice. Any questions?